Hello, ladies and gentlemen. Today, what we're going to go through is domain and range. We're going to talk about how we've given a domain, we find a range. Along with this, we're going to talk about how functions work, what they look like in multiple representations, such as equations, in tables, and in graphs. First thing is, let's take a look at what domain is. And we've talked about this already when we've done our independent variable section. But we've got independent variable, right? All these things mean the same thing. Domain, independent variable, the input that you plug into the function, right? The x-coordinate. These are all the same thing. What you actually input into the function, that's what the domain is. The range is that dependent variable, that answer you're trying to get, the output, all right? It's also the y-coordinate when we look at graphing, all right? One of the things you're going to see is we have this lovely little notation here, this f of x. It's called function notation. It's the dependent variable used when finding the function of x when x equals to a value. Here's the thing. When we look at f of x, whatever the function is, let's just say 2x minus 5, all f of x stands for is your dependent variable. It's just y. It's just another way of writing it. And we'll show you why we write that later on. But if you see if this f of x, it's the same thing as writing y. It's the exact same thing as writing y. It's your y coordinate. Right? That's what f of x stands for. So, one of the first examples we're going to talk about is something you've done before, but we're going to go over a little more today. All right? Given a domain, -3, 0, 1, and 4, we need to find a range of this function. Y is equal to 2x minus 5. All right? As we look at this, we have this lovely little table here. And you guys have seen these tables before. All right? But when we look at these tables, far left column, that is for your x-coordinate, which is your domain. The far right column is for your y-coordinate, which is your range. All right? Now, this middle part, you guys have known it as a process column, right? Essentially what it is, it's the function. In this case, the 2x minus 5. It's what you're actually doing to get that dependent variable. What you're going to do is you're going to take that domain, the -3, the 0, the 1, and the 4, and you're going to put that in for your domain. Under x, we put it in from least to greatest. At this point, what we're going to do is we're going to actually use the input, that domain. And we're going to input it into the function, the 2x minus 5, to get our output, the range, which is y. So as we look at this, 2 times what x is, well, x is a -3. We plug that in. And then you solve this. 2 times -3 is -6. -6 minus 5, same signs, add them together, you get -11. Do the next one. 2 times 0 minus 5. Well, 2 times 0 is 0, and minus 5 is just a -5. We input or plug in next domain in for x. We get 2 times 1 minus 5. 2 times 1 is 2, minus 5 is -3. Then you have 2 times 4 minus 5. 2 times 4 is 8, minus 5 is 3. All right. Now, the whole idea of this is that given this domain, you need to find this range. Now, when we write out the range, it can be written in a lot of different ways, but you also see the range written the same way that the domain was written. So you might see something like this. R equals, and you'll see that little parenthesis. They'll write -11, -5, -3, and 3. They'll write it like that. If you want to pause it and write that down, you can. I'm going to have to erase it here in a second. The big deal about all of this is that we can take this information and you can graph it. We have an x and a y coordinate. So you can make an ordered pair out of this. The first one would be -3, -11. Then you have 0, -5. Then we have 1, -3. Then you have 4, 3. And what you do with this is you're going to plot this on this lovely little graph you have. Well, -3, -11, starting at the origin, you go 3 to the left of the -3 for the x-coordinate, and down 11. You'll see this graph only goes to 10, so we need to make a little dot down here for -11. Okay? The next one is 0, -5. 0, so neither goes to the left or to the right for x, so you're going to go down 5. 1, 2, 3, 4, 5. So that's the point 0, -5. Then you have 1, -3. So here's 1 to the right, then down 3. So that's 1, -3. And then we got 4, 3. X coordinate is 4, so that's 1, 2, 3, 4 to the right, and up 3 for the y coordinate. Hopefully one of the things you'll notice is that this set of points will make a line. Right? It'll produce a line. And what we'll actually do is we'll draw a line through those and show this is the graph for the function y equals 2x minus 5. All right? That's what it looks like. All right. So, let's move on to number 2. What is the range of the function f of x equal to -7 plus -x plus 7 when the domain is -2, -1, 0, 1, and 2? Well, same idea. When we do this, x coordinate is on the far left, y coordinate is on the far right. Your process column is that function, that -x plus 7. And remember, this f of x, it just means y. It's your dependent variable. It's what your answer is going to be. So, if you're given a domain, you plug that domain in for x. That's your x coordinate. Then you have to go through and you have to find y. Well, all we're doing is we're substituting in that -2 in for x. Right? So, what this -x means, it means the opposite of whatever x is. So as we do this, this means the opposite of this -2 plus 7. And that's how you have to write it. The next one means the opposite of -1 plus 7. The opposite of 0. The opposite of 1. And the opposite of 2. Alright? And then you go through and figure these out. The opposite of -2 is 2, so 2 plus 7 is 9. The opposite of -1 is 1, so 1 plus 7 is 8. Opposite of 0 is still 0, so you just get 7. Opposite of 1 is -1, so -1 plus 7 is 6. And the opposite of 2 is -2, so that's -2 plus 7, which is 5. So in this case, what we end up with is we end up with the points -2, 9, -1, 8, 0, 7, 1, 6, and 2, 5. Okay. The range that you found, given this domain, is this 9, 8, 7, 6, 5. Right? And that range can be written as 9, 8, 7, 6, 5. Okay? I want to make sure that's clear. That's one of the ways you'll see your answers written. We can plot this too. -2, 9. -1 to the left, 8. 0, 7, 1, 6, and 2, 5. And you can go through and check those, and you can do them on your own. But hopefully, again, you'll notice a line form. In this case, a straight line. If you're not getting a straight line on these, there's probably something wrong. Okay? All right. So those are the first 2 examples. Let's go to the next one. All right. So this one's a little different. This one is backwards. This one asks, what is the domain of the function y equals 2x plus 5 when the range is 3, 5, 11, and 15? So as you go through this and you look at it, x coordinate and your y coordinate, so your domain, and then your range, you're given the range. You're given the y coordinate, not the x coordinate in this case. Your function is still 2x plus 5. But you're going to have to do something different to be able to find the answer to this one. All right, this one's going to be a little tougher. You need to find the x value. You know what the y value is. So if you look at this, if you have this function, y equals 2x plus 5, when you're substituting in, you're actually substituting in 3 for y. And then what you're going to do is you're going to have to actually solve this for x. You're going to have to solve this for x. And when we do this, this is your two-step equations, which you guys have already learned. All right? A lot of you guys use subtraction to do this. We'll talk about how I teach it here in a little while. Negative 5 plus 3 is negative 2. That's 0, so you end up with 2x. Divide both sides by 2. X is equal to negative 1. So your domain, when the range is 3, is negative 1. You have to do this for each one. You have to plug in the next one. You got to plug in a 5 for y, and then solve this one. So subtract 5 from both sides. That's 0. So over here, you end up with 2x. 0 is equal to 2x. If you divide both sides by 2, x is equal to 0. Right? And again, you have to do this for each one. You have to do this for 11. And you have to do this for 15. All of these have to be done. These take a little while to do. These aren't as fun. We didn't give you as many of these. All these have to be done. But if you do each one of these, you'll get 3 for x when y is 11. You'll get 5 for x when y is 15. So your domain for this one has changed. Is now negative 1, 0, 3, and 5. Okay? Just want to make sure that's clear. All right. Now over here, the next one. If you notice on here, there's really no directions, and there's no domain or range given. So I want to give you this one because this one is one where you're going to make up your own domain. Now I'm going to give you some rules, and you might want to write this down somewhere. If you have to figure out your own domain, I'm going to give you a general rule to be able to figure this out. The rule is, if you have to find your own domain, and you have to pick your own domain to actually find your own range, you want 2 positives, 2 negatives, and 0. Now, as we think about this, 2 positives, 2 negatives, and 0. Well, think of the easiest 2 positive numbers and the easiest 2 negative numbers. Well, majority of the time, when you're looking at this, negative 2, negative 1, 0, 1, and 2 are the easiest. All right? Now, one of the things that a lot of people look at on this problem too is, hey, I don't see an x and I don't see a y. Well, just because we have different letters doesn't mean things change. All right? When we look at this, to figure out what your independent and dependent variables are, it's really pretty simple. The dependent variable is your output, what you're trying to find, the answer. So whichever variable is by itself, this is very important because this will be one of your test questions. Whatever variable is by itself, that is your dependent variable. So in this case, S is your dependent variable. It also stands for your y coordinate. The independent variable is always going to be the one where you're actually producing the function. Right? It's the one that's in the function. So R, which will stand for your x coordinate. Right? I want to make sure that's clear. Dependent variable is a variable that will be by itself. It'll be the answer to your problem. Right? All right, so let's move on. The function itself is this negative 3r plus 14. Given this domain, you're able to pick your own domain, 2 negatives, 2 positives, and 0. Now you need to find the range. So at this point, we just input in the value of r, which in this case for the first one is negative 2. You go through and you solve this. Negative 3 times negative 2 is 6. 6 plus 14 is 20. For the next one, negative 1. Negative 3 times negative 1. Well, that is 3. 3 plus 14 is 17. Plug in 0. Negative 3 plus 0 is 0. Plus 14 is 14. Negative 3 plus times 1. Well, that's negative 3. Negative 3 plus 14 is 11. And the last one, negative 3 times 2 plus 14. Negative 3 times 2 is negative 6. Negative 6 plus 14 is 8. So the range for this one, your range for this one is 20, 17, 14, 11, and 8. That is the range for that function. Given the domain, that input, negative 2, negative 1, 0, 1, and 2, you'll find an output, which is your range of 20, 17, 14, 11, and 8. All right. A couple other problems. Denny Construction Company charges 80 cents for each cubic foot of mulch plus $6 to deliver the mulch. The equation is y is equal to 0.8x plus 6 represents the total charge y in terms of cubic feet x. So in other words, your value of x is your cubic feet. So that's your domain. The range is that value of y, the total charge, how much it costs. Well, so the question asks, if a customer pays $42 for mulch, what would be a reasonable estimate of number of cubic feet purchased? Well, the information you're given is you're actually given the range, 42. So that's it. That's this right here, your range. The problem is you don't see a 42 on here. But what you do see is that 42 would have to come somewhere between that 38 and 54. Well, if that's your range, your domain, in that case, has to come between the two corresponding domains on the other side, which is, in this case, 40 and 60. Right? That's how you read that graph. That's how you read that graph. If you have questions about that, make sure you ask on the next one. Jace receives a gift card of $169 worth of movie rentals at the video store. They charge $7 for each movie rental. You're supposed to complete the table below. So, if you're given a gift card, you don't rent any movies. Think about how much money you would have on that gift card. Well, it would still be $169 because you haven't spent anything yet. You buy one movie, well, you're going to lose $7, so it becomes $162. 2, you subtract another $7, you get $155. And then the last one, you end up with 148. So if you rent 3 movies, it'd be 148. So, the dependent quantity for this situation, real simple. It's whatever the right portion of your table is. It's going to be the balance. Right? What is the independent quantity? Well, it's whatever the left side is. It's what you need to know first. Number of movies. Okay? So I want you to write an equation that represents the balance remaining on the gift card. I want you to think about this. When we write this card, think about what happens here. Each time, this goes down by 7 units. Okay? When we write an equation for these, we always start with our dependent variable, which is B. Sorry. The next thing is we're going to look to see what the rate of change is. So it changes by a -7. So we're going to take that -7 and multiply it by the independent variable, which is n. From there, we need to look to see where we start. We call this our initial value. Your initial value is what you add on to an equation. It's where you start at. We started at $169. So that's what you're going to add on. So we end up with B is equal to -7n plus 169. So describe what's happening to the dependent quantity after each movie round. Real simple. It decreases by $7 every time. Alright, so hopefully that helps you out a little bit. If you have any questions, bring them to class. If you need to read any of this, to not read. If you need to review any of this, rewind it, watch it again. Bring your questions to class and I'll help you out. All right, guys. Have a good day.